and bases, right? So what exactly are acids and bases? So we have different theories for acids and bases, right? Just pay
Yeah.
attention. What are we exactly going to do? We are going to study about the Arrhenius theory. Okay. And just follow me. Okay. I understand you understand a lot of things, but there are certain things that I need to explain. So I have to go a little bit into basics, but that will make things easier. Okay.
Okay, yeah, that's fine.
Awesome. Thank you. So we have Arrhenius theory, and then we have the Bronsted theory. And then we have the Lewis theory. All right. So we have the Arrhenius
Yeah.
theory, the Bronsted theory, and the Lewis theory, or acids and bases. All right.
Yes.
All right. Now understand. So when we are talking about the Arrhenius theory and the Bronsted theory and the Lewis theory, what does that mean? We see. So according to Arrhenius, the substances which give off H plus ions in the aqueous solution. So Arrhenius theory is primarily a theory defined to have aqueous theory. That when we define that something is an aqueous medium, when some acid or base is being dissolved in water, then in water, when it gives off H plus ions, which is going to be my hydronium ions, is going to be my what? When it is going to give me my hydronium ions, then what do you think is going to happen? Which gives hydronium ions? Then I'm going to say that they are going to be acids.
Yes. Okay, I remember that.
Got the point? And
And it's
similarly, the
strong if
substances
it
which
gives
give
it up
off,
easier, right?
yeah, I'll tell you why. So which of the bases gives
Bases are
OH
like
negative
OH
ions?
plus. O negative. Okay, got it.
OH negative. This is called as hydroxide ions. So the substances which give a lot of OH negative ions will be called as a basis. Okay. Now understand. Now, there's a very important concept. Okay. What is that? So Bronsted theory basically is about, again, in the aqueous medium, but it primarily deals with what? It primarily deals with the protonic concept. What is protonic concept? That it deals only with H plus. Okay. Why does it deal only with H plus? Just understand. For example, substances which give off H plus. Substances which give off H plus in its aqueous medium, which give off H plus in its aqueous medium, is an acid. And the substances which gain. So you understand that when we talk about the hydrogen atom, what exactly does that mean? So we have a nucleus, right? The hydrogen atom is one proton and one electron. So when we say that one proton is equals to one electron, what does that mean? Simply tell me. That when I say it has one proton and one electron, that means what? That the electron here shall be attracted to proton. That the electron here shall be attracted to the proton. And somehow, if I end up doing what? Somehow, if I end up losing what? Somehow, if I end up losing, right? What does that mean? That if that one electron is lost, so we are left with only one proton, and hence H plus is basically just one proton because we are losing onto one electron. Are we understand? So that is why
Hmm.
once you lose one electron, initially we said that one proton is equal to one electron. So the charge of one proton is plus one. Charge of one electron is minus one. Net charge is zero. Okay. But if one electron is lost, then we are left with hydrogen plus one ion. But actually, it has only one proton. Are we understanding? Actually, it has only one proton. Understood my point of view? Is it clear?
Yeah.
Right?
Yes.
So first thing you have to understand that substances. So that is why Bronsted concepts, no matter it is a aqueous medium, okay, but it basically means what? That it is actually a protonic concept. It deals with only H plus. The substances which give off H plus ions in aqueous medium, they are called as an acid. And the substances which gain H plus ions is called as a base. All right. So these are the two
Hmm.
theories we have to understand. So from here you understand, according to Arrhenius, what do we say? That the substances which give off H plus ions. So same concept we are saying in the Bronsted also. You understand? But instead of calling it as H plus, we call them as protons. So what do you say? We say that
Right. Yeah.
all Arrhenius acids are Bronsted acids. All Arrhenius acids are Bronsted acids. Are we understanding? All Arrhenius
Yes.
acids are Bronsted acids. Yes or no?
Okay. Yes. So there's three theories.
Correct? So for example, you understand. So if I say HCl, the first thing you understand that when we have a bond, you understand that there is a H here and there's a Cl here, and one, two, three, four, five, six, seven, right? So this makes a bond, right? So you understand that initially hydrogen has one proton in its nucleus and chlorine has 17 protons in its nucleus. So you tell me whose nucleus is stronger? Whose nucleus is
Chlorine.
stronger? All right,
Chlorine. Yes.
right? So initially the bond when it is formed, that means initially the bond when it was formed that these two electrons were exactly in between. These two were exactly in between. Yes or no?
Yeah.
But the moment the bond is formed and becomes stable, the chlorine 17 protons, they do what? They pull the electrons towards themselves. So you understand that how does it look like? Got the point?
Hmm.
You get the point.
Yes.
So you understand that these cross electrons, one, two, three, four, five, six, seven. These seven electrons are of chlorine itself, but an extra electron of hydrogen has come to the side of chlorine. So chlorine acquires a partial negative charge and hydrogen acquires a partial positive charge. So delta plus is called as my partial positive and delta negative is called as my partial negative. Okay, now understand.
Yeah.
Okay, so now when you put this in water, you understand water is also polar. Water also carries some charges. Hydrogen carries a partial positive charge. Oxygen carries a negative charge. Why? Because these electrons get shifted towards oxygen. So what do you think we're going to have? So once you put HCl in water, what do you think is going to happen? We have HCl. Got it?
Yeah.
Got it?
So the H is gonna get pulled away.
Yeah. So what is exactly going to happen? Just tell me. That this
The
positive
H will
charge,
get pulled away.
they're going to pull away and they're going to break this bond. And once they're going to break this bond, chlorine will take away all its own seven electrons along with that one extra electron of hydrogen. And here,
Hmm.
chlorine is going to come out in the form of Cl negative and H plus. Are we understanding?
Yeah. Okay.
Okay. But you understand that HCl when we have, so initially you have to understand that HCl when it is in the gaseous state is
Right.
not going to
Okay.
break down on its own. You need something to break it
Yeah.
down. Okay.
Okay.
But who is breaking it down here? Water is breaking it down. You understand? Who is breaking it down here?
Hmm.
Water is breaking it down. Understand? Normally, on its
Yes.
own, it
Okay.
would not have been broken down. But here, what is breaking it down? Water is breaking it down. Okay, now understand. If you call something as a strong acid and if you call something as a weak acid, please pay attention. Let's say we have HCl, we have HF. Okay.
So this is
Let's say
strong,
we have
right? Because
HF.
the H is like easily broken in this case, so that means it's a stronger acid.
Yeah. Why is H is easily broken down here?
Because the partial, like, because it's in water already and the oxygen is partially negative and the hydrogen is partially positive. So they want to like balance each other out. So it kind of just pulls it away.
Yeah. So why is that not happening on HF?
Why is that not happening on HF? Oh, because
Why is that
F is
not happening in
super
HF? HF is a weak
electronegative.
acid. Sorry.
Yeah, because F is super electronegative. So it's like pulling H towards it as much as it can.
Okay. What else?
Um, I don't know.
Mhm. Okay. Now let's come to this one. Understand. So we have Hs. Now understand. Okay. H is this atom. H is a standard size. Chlorine is having this size. So you understand that when you have H and F, so you're going to have H and you're going to have F, and
Well,
they make
F
a
has a
bond. When they
smaller
overlap,
atomic
so
radius, right?
understand. So we have two electrons
Because
here in the center, one from F,
wait, is it
one
just
from
that
F.
F has a smaller like atomic radius, so that means the centers are like closer for H and F, so then their bond is like stronger or something, right?
Yes, yes. So you understand that these two electrons, when they come here, they are getting an attraction from these two nucleus, which is very close. But let's say if I talk about an HI acid, so fluorine, then we have bromine, chlorine, then we have bromine, and then we have iodine.
Okay.
So what does that mean? So you're going to have H making a bond with iodine. The bond will look something like this. The bond will look something like this. So this is going to be HCl. This is going to be my HPr. This is going to be my HI. So you understand that hydrogen is not changing its position.
Yes.
So here you get the attraction from two different sides. Here you get the attraction from bromine. Iodine gets even farther off. So can I say the HI bond is the longest and the weakest? Because the distance between the two nucleus is actually the bond length. The distance between the two nucleus,
Yeah, I remember this. Like the longer bond distance is weakest.
you get the point. So the
Yeah.
distance between the two nucleus is the bond length. So the longer the bond length, the electrons are
So
experiencing the
what are
attraction
all the
from a very
things I
far off.
need to like consider? So I need to consider electronegativity, right? Like that's one thing. And then I also like for F, we don't really consider electronegativity, but shouldn't we also consider that as like part of it or no? Like for HF.
Down the group, when we go, we consider only the size. Along the period, we consider the electronegativity. So what you're trying to do is you have been taught the concept, but you are trying to apply both the concepts in along the period and down the group. When you make an acid and
Wait,
then you compare the acids down the group, you compare them only on the basis of their bond length. And along
oh
the
like
period, you
so
compare them on the basis of their electronegativity.
wait, so like because you're saying F and Cl, so we're only comparing bond length in this case?
Yes, yes.
But isn't electronegativity also the same way? They're kind of like anti-parallel, right? So why do we not like I thought electronegativity was also to the right and up is like higher electronegativity. So isn't that also like kind of based on rows? I'm a little bit
No.
confused there.
Down the group, the major trend comes from the bond length. And I'm not denying that electronegativity does not play its role. It plays its role. But that is
Wait,
very
can
minor.
you
The only role of
what do you when
electronegativity
you
is to
say
pull the
down
electrons
the
towards
group, what do
fluorine,
you
chlorine, bromine
mean?
ion. Sorry?
Wait, what do you mean when you say down the group? Like down each column? Like
Yeah,
if
down
we're
each
going
column.
down, I
Yes.
should so if it's going down the column, I only consider bond length. And if it's going up, I consider like is it up and down or like in what direction do I consider which thing?
Okay, understood. I'm telling you. Do you have this periodic table? Hydrogen, helium,
Yeah, I have it
lithium,
pulled up.
beryllium,
Yeah,
boron,
yeah.
carbon, nitrogen, oxygen,
Yes.
fluorine, neon. Then you have
So as far as
sodium,
I
magnesium.
understand it, this way, this is increasing electronegativity,
One
and then
second.
this is
Let me speak. One
increase.
second. Let me complete. Aluminum,
Okay.
silicon, phosphorus, sulfur, chlorine, argon. Then we have potassium, calcium. This is like that. That's the periodic table, right? So if you make a table like this, if you go like this along the black line horizontally, so the acids that you make is BH3, CH4, NH3, water, and HF. So here H has to be released, but along the period we say that the one having more electronegative element creates stronger acids. When I say stronger acids, they mean to release more H plus. But when we go down the group like that, down the group. So in the group 17, if I go down the group, so acids will be HF, HCl, and HI. For water, we are going to have H2O, we are going to have H2S, we are going to have H2SE for this group. So if I ask you which is going to be a bigger element, I'm going to say tellurium is going to be a bigger element. So the longer bond lengths you will have in H2TE. And when you have the longer bond lengths in H2TE, what does that mean? When you have longer bond lengths in H2TE, what does that mean? When you have longer bond lengths in H2TE, what does that mean? They will release
And
H plus faster. So down the group, the acidic strength you decide on the basis of the bond length. And here along the period, you decide acidic strength on the basis of
electronegativity?
yes.
Wait, I don't understand why though, because my question was since they're like anti-parallel, why do we only like that doesn't make sense to me. Like if
I'm telling you. Let
electronegativity
me
gets
explain.
stronger like this way, right? To the right and then up, like why I'm confused. Oh,
Yeah,
actually
let me
that does
explain.
make sense.
Let me give
Wait,
you
it's okay,
clarity
I
on it.
get it. Because bond length is this direction. So obviously if we're going down, then we consider bond length. That makes sense. That's probably it, right?
Okay, got it?
Is that right? Though was my like assumption there, right?
Yeah, let me explain this. One thing. So, okay, so we are going down, right? Now understand. So HF is a smaller bond, got it? So now what is required here? Understand. When you have an acid like this, we have a partial negative charge, we have a partial positive charge, and you understand that fluorine is more electronegative. So it attracts the electrons toward itself. And once it attracts the electrons toward itself, what does that mean? Once it attracts the electrons toward itself, what does that mean?
And
That
it's the
ma'am, it is
bond
going to
is
have,
shorter, so it's stronger,
it
so
is
it's
going to
harder to
attract
break.
water strongly
So it's a
because
weak.
more the negative charge, more the positive charge, there will be a lot of attraction between this.
Oh, isn't that the case for water? So, like, I don't understand why it's so, like, the example we just did with HCl, right? Wasn't that kind of the same thing where we were just saying that, like, if it's
Yeah.
either partial negative or partial positive, it's going to attract the water?
But
So, if
what is
there's,
the
is it
negative
just
charge?
a,
How will you, listen to me. How will you compare the negative charge on fluorine and how will you compare the negative charge on fluorine?
like, fluorine is a lot stronger, but I'm saying either way, is it just that if there's any charge at all, then the water is just
No,
attracted to
no,
it?
no. Water will be attracted, but the strength with which the water is pulling it will depend upon the charges between H plus of water and a negative charge of F negative.
Oh,
HCl
so
will
like
not
in
have that
this
much negative
case,
charge.
okay, so in this case, since F is really electronegative, it's pulling the water to it instead of the water pulling it the other direction. So the bond is like being harder to be broken.
That is one thing. But if water also tries and pull it back because the strong bond is very strong. So this bond
Yeah,
doesn't
and the
break easily.
bond is strong because the bond length is short, right?
Yes. Yes.
Okay, got it. That makes
Got
sense.
it? So now when you
Yes.
go to HI, HI has what kind of charge? You tell me. HI has less charge because iodine
Let me
is
look at
less
my periodic
electronegative.
table. Yeah. So it's
It
less
attracts water, water
electronegative
tries and attracts
and
it.
it but it has more of a the radius is bigger, so it's farther apart, right?
The electrons lie here, but the iodine is attracting it from very far off because iodine size is very big. So the
Yeah.
nucleus
Okay,
of the
great. So the
iodine is very
bond
far
length
off
is
from
longer.
the shared pair of electrons.
Okay. So in
So
this
the
case, the
attraction
H
that
can
iodine
break
is
off
giving to the shared pair
easier.
of electrons is very less.
Right. So in this case, the H can break off easier, right? Because it's
Yeah,
the both things are true. It's less electronegative, so it's not pulling the H as close, and it's bigger, so it's also not pulling the H as close. So the entire bond is just weaker, so it's easier to be broken. So this is a weak, or no, yeah, this is a weak acid, right?
which one
The HI, this is a weak
is a
acid.
weak acid? No, HI is a strong acid.
Oh, right, sorry. It can be broken easier, so it's a strong acid.
Yeah,
Okay. But it's not broken, right? Or the correct terminology is like how easy it is for the H to be pulled away from, or I guess it's how easy it is for the bond with the H to be broken. Is that what you're saying?
yes.
Okay, got it.
Okay, now understand. So you have to understand that if we are given a strong acid, okay, now understand. Or if I give you a strong base, now understand very important thing. So every acidic solution and every basic solution has what? So understand. Let's say I take a beaker and I add water. So you know that every acid will break down into H plus and A negative. But at the
What
same
is A
time,
negative?
like HCl, HF, HI,
Oh, it's
one negative ion,
A
and
minus
I,
is just a placeholder. Oh, so just a
yes,
negative ion. Okay.
yeah, one negative ion. Because every acid is going to give me H plus. Okay. So once we have H
Mhm.
plus and A negative, what does that mean? Just a second. So it breaks it down. And once you break it down, what do you get? You get H plus and A negative. You understand? Now, what is
Yeah.
happening? Just understand that every acidic solution, when it is being pulled apart by water molecules, when it is being pulled apart by water molecules, correct? So H plus and A negative are separated, but sometimes water also breaks down. So water is giving its own H plus and OH negative ions. But water breaks down to a very less extent. Water breaks down by a very less extent. And when water breaks down by a very less extent, so we are going to have what? We're going to have H plus and OH negative. Do you understand my point?
Yeah.
So you understand that this acidic solution will have H plus coming from both water as well as acids. Got it? But OH negative comes from only water. But OH negative comes from only water. Got the point? Got it? But if you have a basic
Yes,
solution,
yes.
let's say if I have base NaOH, so how do you think NaOH will break down? NaOH will basically break down into what? It is going to break down into Na plus and OH negative. Got the point? So
Yeah.
how does NaOH break down? NaOH will have its own Na plus OH negative. So water is trying to pull them apart, hence OH negative, a lot of OH negative is produced from the base. But if you have water, it will also break down into H plus and OH negative. Got the point?
Hmm.
So what does that mean? What does that mean? That means in a basic solution, H plus ions are there and H plus ions are coming from water, right? From water. And OH negative ions are coming from water as well as base. OH negative ions are coming from water as well as base. That means total OH negative ions here we have what is definitely going to be more than what? H plus. Total OH negative ions are going to be definitely more than H plus. Yes or no? So the idea here is what? The idea here is what? That when we are talking about the total OH negative ion, you understand? So when we are talking about the total OH negative ion, so can I say that in the acidic solution, both H plus and OH negative ions are present, but H plus is way more than OH negative ions. Whereas in the basic solution, both OH negative ions and H plus ions are present, but OH is way more than H plus ions. Am I right? Got it? Yes or
Yes.
no? So the idea here is
Yeah.
what? The idea here is that H plus will be definitely more than lot of OH negative ions, and OH negative will be definitely more than lot of H plus ions. Are we understand? Okay. So that means
Yeah.
every solution will have both the ions. So if I tell you the number of H plus ions we have per liter in a solution, and if I tell you the number of OH negative ions per liter, okay. If I tell you the number of OH negative ions and the number of H plus ions per liter, you understand? So then that is going to be what? So every solution will have both the ions, the H plus ions and the
Yes.
OH negative ions. So I have to know that
Okay.
if you have a 1 liter solution of the acid plus water ends up to be 1 liter, in that how much H plus ions we have? Let's suppose if I say the H plus ions we have is let's say 2 into 10 raised to power minus 4 moles of H plus per liter. Am I right? So 2 into 10 raised to power minus 4 moles per liter. If let's say we have this, okay? So then what do you think is going to understand? Tell me.
That.
So if I want to calculate the pH, got the point?
Wait,
So the
I don't
pH formula
understand
is
what
minus
you
times
mean
log of
by.
H plus and concentration. Sorry.
Oh, yes. Never mind. Sorry. I do vaguely remember this formula.
So this square brackets means moles of H plus per liter. Are you understanding? And similarly, the formula of POH here is going to be what? It is going to be minus times log of square bracket OH negative. What does that mean? Then it is moles of OH negative per liter. You understand my point?
Oh, so they're both the same. Like the formula is basically the same. It's just the negative log of the thing.
Yeah.
Okay.
So if I have to
I thought there
calculate
was
pH,
something you had to do where I don't know if this was like maybe just for a specific question, but sorry, never mind. I don't remember what it is off the top of my head. I will maybe send you the question later. I remember some like distinct question that was a little bit tricky.
so you're going to have pH is going to be minus times log of H plus. Got the point?
So this is like the log of, do we include the -2 for this one?
pH here is going to be minus of log. What do you mean by log? You tell me first of all. Do you know log?
Like log base 10, so it becomes -4. Like if we just took the log of 10 to the -4, then it just becomes -4. And the negative log of that is 4. But like, do we include the 2? Like that's part of the H plus?
Yes, we have an identity for
Okay.
that. Just understand. If you can break it down log A into B,
Well, yeah, yeah,
that
yeah,
is
I
equals
know
to
that. You can
log
like, you
A
add
plus
them.
log B.
Yes, yes. I'm a math major. I know the log, the basic log things.
Log A by B is going to be what? Log A
So
minus log
log
B.
2 plus log, yeah,
Got the point?
yes,
So now if you have to calculate the pH given the data, so you will have minus times log of 2 into 10 raised to power minus 4. So this pH basically becomes what? Minus times log of. So minus you keep outside. This becomes log 2. This becomes log 2 plus log 10 raised to power minus 6. So pH here is going to be what? Minus log 2 to the base 10 is basically 0.30. You can use the calculator. And log 10 is to minus 4 comes to the forward. So log 10 to the base 10 becomes 1. So the pH here is minus of 0.3010 minus 6. Am I right?
okay, yeah,
So pH here becomes what? 4 minus 0.3, that is 3.7 with a minus sign. So that
yeah,
becomes plus 3.7.
yes,
So pH here is going to be equal to what? 3.7.
yes.
Okay. Now you understand that every solution
It has
has
both of
both
them.
pH and pOH.
Yeah,
Because every solution contains H plus ions and OH negative ions, but one will be more and one will be less. If H plus is more, you call it as acidic. If OH negative is more, then you call it as basic.
yes,
So the idea here is going to be what? Just tell me. So we're going to say pH. This pOH here is going to be 14. pH is 3.7.
oh, so
pOH I don't know.
11.3. No, it'll be
So pOH
10.3.
here is
Sorry,
going
my
to be what?
bad.
14 minus 3.7. And that's going
So
to be 11.3.
yes, 10.3. 10.3, no?
10.3. Got the point?
Yeah,
So you have to remember this formula that pH and pOH is definitely going to add up to 14.
yeah,
Understood?
yes.
Any doubts or
Uh,
not?
no, I get this. Yeah, this is chill. I get this.
Got the point?
Yeah,
That is one thing. Now understand. So if let's suppose if I'm given the base for the base, For the base, let's say we have KOH, and they give me it is going to be zero point 0.1 molar, and I know it's a strong base. So how does KOH breaks down in the presence of water? It gives me K plus and it gives me OH negative. Am I right?
Why does that breakdown only happen in the presence of water?
Sorry.
Like, what do you mean the breakdown only happens in the presence of water?
If water doesn't pull it, how will you think? Because otherwise, K plus will
Mm,
be
got
attracted to
it.
OH negative. So
Okay,
water
yes.
has to be there to kind of break it. Are we understanding? Got it? So if water doesn't pull it
Oh,
apart,
wait,
they
one
will stay
second.
together.
How does OH become negative?
So 1, 2, 3, 4, 5, 6. O's atomic number is 8. Configuration is 2, 6. H is a non-metal. It forms a covalent bond. So oxygen needs to complete 2 electrons to complete its octet. So 1, 2, 3, 4, 5, 6, 7. So oxygen now has 7 electrons with itself.
Wait, so
And
then
then we
that's my
have
question.
potassium.
Like, isn't it automatically just on its own negative?
No, but potassium is 1. It donates its 1 electron here. So potassium
Oh,
becomes plus 1. OH is basically
wait, but
covalent
that's
bond here.
like in the full like molecule, like the KOH, there it's like no charge. But if you just take it separately, doesn't it have a charge? Like OH on its own has a charge. Like, how is
OH
that coming
minus
from the
does not.
water?
Yes, it has a charge. It has a charge.
But then how is that? I don't understand how that's coming from the water. Like, if it already has that charge, what is the water doing to like give it that charge? Like, doesn't it already have
K
it
plus,
before
listen
it
to me.
even
K
comes in
plus and OH
contact?
negative here. Can I explain?
But this is like when they're together, right? I'm saying like let's say there is no K plus, it's just OH, then it's just OH negative.
So then OH negative is attracting water, like from the positive end, and then water is surrounding it. You get the point.
No, I still don't get it.
Let me explain. Let me complete my explanation. Then your doubts come exactly in the middle. I'm so sorry to say, but then I lose my track.
Yeah, sorry, that's fine. Go ahead.
So if I have this beaker and I have K plus and OH negative, so they have this attraction, right? Now, if you put it in water, water, you know that water has negative charge on O. Water has negative charge on O, and that is going to pull K plus away. Similarly, H of water has positive charge. H of water has positive charge, and it is pulling it apart. So KOH breaks down. But if you're asking that if OH negative is alone, OH negative got its negative charge from potassium. You understand? O made a covalent bond here with H. So oxygen's basic idea is to complete its octet. So it is going to get 2 electrons. So what does that mean? It is gaining one that electron from hydrogen. So now it has 1, 2, 3, 4, 5, 6, and 7. And 1 electron it gains with potassium. So it gets OH minus 1. Solid state, if you look at them, that so in the solid state, this K plus and this OH negative, they have the attraction with them. So that's what keeps it in solid state. But if in water, if OH negative separates out, then OH negative has to remain independently because it has gained that 1 electron from potassium to acquire that negative charge. So in the aqueous state also, OH will do what? OH will gain that, keep that electron and still remain OH negative and it becomes positively charged. So what does that mean? Just tell me. So we are going to have like this. We are going to have something like this. And that water, because H is positive, so it attracts itself to O negative. So that attraction does not let OH negative lose its 1 electron, because of which it is becoming negative. Because it is getting the layer of water around it. And that layer of water makes it very, very stable. So which is why OH negative does not lose its electron. Are we understanding?
Yeah, that kind of makes sense.
You understand? See, it's very simple. I have
Yeah.
a lot of friends because let's say I have something with me, some special thing, and a lot of people want to have an access to it. The people are surrounding me only because to have that thing, which only I have. So I will not like
Okay.
to lose that. Similarly, OH negative is negative because it has that one electron.
So is it kind of the same explanation for K then? Like because it has the positive
Yeah,
charge, it's also being surrounded? Okay.
yes, yes. Okay. Now understand.
Yeah.
So what I'm trying to tell you is that let's say if I have a KOH base, that KOH base will break down into K plus and OH negative. And let's say the initial concentration is given to me. They have given me it is zero point 0.1 capital M. What do you mean by capital M? You read it as molar. So this is basically zero point 0.1 molar. So when it is zero point 0.1 molar, molar would mean zero point 0.1 moles per liter of solution. And moles of what? 0.1 moles of solute. So you understand that when I make a solution of KOH, when I make a solution of KOH, what does that mean? Just tell me. When I make a solution of KOH, what does that mean? That KOH plus water is my solution. And obviously, KOH is going to be my solute, and water is going to be my solid. So when I say molarity, I am given the moles of solute in liter of solution. That means if I add 10 ml of this and 990 ml of water, my total solution adds up to 1000 ml, which is nothing but 1 liter. So total solution is composed of the solute's volume as well as the solvent's volume. And the moles is basically of the solute, all this. So in the question, I know that no matter how much large is the solution, KOH is being my solute, it is going to have zero point 0.1 moles. Okay. KOH here is going to be what? This is going to be zero point 0.1 moles. Am I right or not? So you understand that
Mhm.
when we have KOH, it's going to be zero point 0.1 moles. So this is going to break down into zero point 0.1 and zero point 0.1 because it is a strong base. Strong bases, they dissociate fully. So all the moles we have, they're going to dissociate fully. But you understand for bases, we do not have H plus ion concentration. The very first thing that we get for bases is the hydroxide ion concentration. So how do we calculate? What do we calculate for them first? pH we calculate for them first, or POH we calculate for them first. So POH is going to be log of OH negative, and pH is going to be minus times log of H plus. So you understand that when we have pH and when we have POH, so pH is going to be minus times log of H plus, but KOH solution has very less quantity of H plus ions and very large quantity of OH negative ions. Am I right or not? So as a result, you understand it is beneficial for me to calculate POH first for bases. Because in bases, the most high amount of the concentration is of the hydroxide ions, and that will be easily available for me. So then what do? We simply say POH here is going to be what? Minus times log of 0 0.1 because that's the value I'm getting per liter. And once I do it, it becomes what? So POH here becomes what? It becomes minus times log of minus times log of 1 over 10, which is basically minus is there, it becomes log of 10 raised to power minus 1. So then what do you think POH here is going to be? POH here is going to be minus is outside, it becomes minus 1 log 10 to the base 10. Are you understanding?
Yeah.
And this becomes plus 1. So this is going to be my POH. Understood my point? So for the bases, they will be giving me the POH is better. And then we can apply the formula that pH plus POH is always 14. So pH we do not know for this expression, but POH we have calculated. So pH here is going to be 13. Are we understanding this part?
Yeah.
Yeah. So for bases, the first thing that we calculate is POH. For example, similarly, if I give you strong is, let's say, CaOH whole twice. So this gives me Ca plus 2 OH negative. And let's say somebody gives me the concentration is 0.04 molar. Molar is always for the solution. So how do I replace molar? 0.04 moles of solute per liter of solution.
Mhm.
What solution do you think we have? We have a solution of calcium hydroxide plus water. So once you have a solution of calcium hydroxide plus water, what does that mean? Just tell me.
So the calcium hydroxide is the solute and the water is the solution.
Yes. So this is the solute. So basically, the question has given me the solute of CaOH whole twice is going to be 0.04 molar. Are we understanding?
Yeah.
So what does that mean? What does that mean? Just tell me. We have this. So CaOH whole twice will give me 1 Ca plus 2 because 2 here is coming from the valency of Ca plus 2. And if you see nothing here, it is 1. So this becomes OH minus 1. So we get 2 OH minus 1.
Right. Okay.
So you understand. So one molecule, if it breaks down, it is basically composed of one calcium ion and two hydroxide ions. Only then
Yeah.
you see overall calcium hydroxide is neutral. If you look at this, if you see overall calcium hydroxide is neutral, what does that mean? So we're going to have Ca plus 2 and we're going to have OH negative and OH negative. That is how minus 1 adds up to minus 2 charge and calcium becomes plus 2. So we have calcium plus 2 and 2 hydroxide ions. Am I right? So that means if I have
Hmm.
1 here, it becomes double. If I have 0.04 moles per liter, so this is going to become 0.08 moles. You understand my point? And now, because it is a base, it is very much convenient for me to calculate POH because I straight away know the concentration of POH, OH negative ions. And you understand, we have a beaker, right? We have filled in this beaker some amount of calcium hydroxide, and the remaining amount we have filled in with water. The remaining amount we have filled in water. So when we have filled in the remaining amount with water, what does it tell me? When we have filled in this remaining amount with water, what does that mean?
So we're
That
diluting
means
it
if this is
more,
going to be, let's say, 20 ml, this is going to be 980 ml.
right? Yes.
So what does that mean? In this beaker only it starts to dissociate. So every calcium ion will break down into Ca plus 2 and OH negative, OH negative, OH negative. Yes or no?
Yeah.
And when it starts breaking down into OH negative, OH negative, OH negative, what does that mean? Tell me.
That it's
That means in the same liter, we have these many moles. So this is basically 0.08 moles per liter. Am I right? So now if I have to
yes.
calculate the POH, I'm going to say it is going to be minus times log of OH negative ion concentration. So this becomes minus times log of 0.08. So this becomes minus times log of 8 over 100. Are we understanding?
Wait, I don't get how you did the calculation. Oh, wait.
Got
Never
it?
mind, never mind. I got it. Okay, yeah. Yeah, this is good.
So this is going to be what? This is going to be minus times log of. Now 8 over 100 can be written down as 8 into 10 raised to minus 3. I'll tell you how. You understand. When you say 10 raised to power 5 divided by 10 raised to power 2. So when bases are
Yeah,
same, the
I get
powers
what you
get
did.
subtracted. You write this out.
Yes. I'm a math major. You don't have to explain like the basic math concepts to me. I get this stuff.
You get this?
Yes.
Okay. So that's fine. So I am writing it down. So stop me whenever you don't get it. So it becomes minus
Okay.
times log of A into B is log A plus log B. So I keep minus log outside. It becomes log 8 plus log 10 raised to power minus 6. So what do you think I get? Minus is outside. So this becomes log 8 plus log 10 raised to power minus 2. Log 8 is basically 0.9030 and this becomes minus 2 times log 10. So you have 0.9030 minus 2. So this becomes 2 minus 0.9030 And this basically is tentatively around 0.790. 1.0970 is going to be my POH. And I know for every solution there are H plus ions also and there are POH ions also. So you understand that pH plus POH here is going to be 14. POH I know is 1.0970 plus pH is going to be 14. So that means pH here is going to be what? 14 minus 1.0970 is going to be my pH. Understood the point?
Yeah.
Understood the point or not?
Yes.
Okay. So you have to understand that whenever we give the base, we first calculate the pOH and then we calculate the pH. Whenever we are given the acid, we first calculate the pH and then we calculate the uh, pH. Then you understand there is another concept. So you understand this pH and pOH stuff. I'm going to come to more questions like that. But for now, and we need to practice a lot because there are a lot of variations in that. But I suppose you understand the concept of an arrhenius acid or an arrhenius base. That you first put it in water, then water pulls them apart. When water pulls them apart, water gives them either H plus or water gives them either OH negative. Accordingly, accordingly, if you have a base, it does not mean that it is not going to have H plus ions. It will have H plus ions, and accordingly, it does not mean that it is going to have OH negative ions. It is definitely going to have that. But at the same time, what is happening? This is the point, right?
Hmm.
So every solution will have both H plus and both OH negative ions. So for every solution, we can calculate pH and pH. There is another formula that you need to remember that the concentration of H plus into OH negative ions is always going to have a product of 10 raised to minus 14. Okay. So for
Yeah.
example, you understand, and this is at 25 degrees Celsius, which is my room temperature. So you understand what is happening. Let's say if I give you a question that, I have HCl acid and I have 0.01 molar of HCl. So you know it's a strong acid. So it breaks down to give me H plus and Cl negative. So one molecule breaks down to give me what? One H plus. One molecule breaks down to give me what? One H plus, which is going to give me 0.01 molar H plus. So I kind of know the H plus ion concentration, but I also know the fact that this could not have been broken down without the presence of water. So water will be there, and then water will be breaking down into H plus and OH negative. But you understand that water does not breaks up into a lot of ions. Water breaks down very slowly.
Yes.
Water breaks down into very small quantities.
Yep.
So it gives you a very minor quantity of H plus and it gives you a very minor quantity of OH negative. Are we understanding?
Yeah.
So you understand. So when we have this HCl and when we have water into it, so what does that mean? So it is going to be 0.01 molar. Got the point. So if I ask you that what is
Hmm.
going to be the OH ion concentration in the beaker, you have the formula for that. So that is going to be 10 to the minus 14. So H plus here is going to be 0.01 and OH negative we are supposed to calculate. This is going to be 10 raised to the minus 14. So once we have OH negative is going to be what? 10 raised to the minus 14 divided by 0.01. So it's going to be 10 raised to the minus 14 times 100. So OH negative here is going to be what? 10 raised to the minus 12. So you understand that OH negative ion concentration is 10 raised to the minus 12, which is very, very small than the H plus ion concentration, which also includes concludes what? That it is
That it's
definitely going to
acidic.
be acidic,
Acidic. Yeah.
right? And if I
Okay.
know the OH ion concentration here, can I straight away put it into the formula of POH? So from here, you
Yeah, you
understand that
can.
POH, you have what? 10 raised to the minus 12 is
It's
very
12.
small quantity.
Yeah.
So if you neglect the minus sign of this outside, the overall, if this is small value, you understand this is going to come out to be minus 12. But because of the outside minus, it becomes a plus 12.
Yeah. So
So
it's
do you
super, super
understand the
basic.
point? You understand the point that for log, you understand. So let's say if I say log 10 is what?
I understand how logs work. I don't need further explanation on the logs.
Okay. So I hope you understand that log 10 is 1, log 100 is 2. But if I put a minus sign, what I'm trying to tell you is कि if, for example, we have this input, bigger thing, bigger number, bigger value. Log 10 is 1, log 100 is 2, log 1000 is 3. You increase this number, the value keeps on increasing. But if you put a minus
Yeah.
sign, the value keeps on decreasing.
Hmm.
That means what does minus do to this log? That if you have a smaller value, its POH value is going to be bigger. That means understand. So if I say pH of a solution is let's say 5 and pH of a solution is let's say 3 or 1, who do you think is going to be strongly acidic? So for acid A, you say minus times log of H plus is 5. So when the base is 10 here, you take minus on the other side. So this becomes log of H plus is going to be minus 5 to the base 10. How do we get the value of H plus? That we know that 10 raised to power minus 5 gives me this H plus. 10 raised to power minus 5. Do you understand this part?
Yeah.
And here we have minus times log of H plus as 1. So I take minus on the other side. So this becomes what? Log of H plus. Here is going to be minus 1 to the base 10. So log of H plus here is going to be what? 10 raised to power minus 1. Got the point? So what does that mean? Tell me. What does that mean? So it is exactly going to be what? That H plus ion concentration will be 10 raised to power minus 1, which is going to be 0.1. And this is
Yeah.
going to be 1 upon 10 raised to power 5, which is going to be 0.00001.
Hmm.
So you understand, whosoever's pH is greater has less H plus ion concentration. Whosoever's pH is lesser has greater H plus ion concentration. And whenever you have greater H plus ion concentration, what does that mean? That means it is more acidic. So that is why if you have a pH 1, it will be more acidic than pH 5. Are we understanding my point?
Yeah.
Got the point?
Hmm. Can
Any
we
doubts?
wrap up here for today?
Yeah, sure, no problem.
Okay.
All
I
right.
feel like I have a good understanding of this then for now.
Sorry.
I think I have a good understanding of this today. Like maybe we can do a little bit longer tomorrow.